Hi guys! Welcome sa Engineered Math Channel. Sa video na to ay tuturo ko sa inyo ang families of curves. So kung gusto niyo itong matutunan, just keep on watching.
Okay, itong families of curves, application siya noong elimination of arbitrary constants. So, di ba sa elimination of arbitrary constants ay meron tayong equation with certain number of constant at in-eliminate natin yon by finding the derivatives of the given equation at yung number ng derivatives na bubuuin natin ay base dun sa number ng constant. So, kasi itong family of curves, ito yung solution natin sa differential equation, which is a function na merong constant. So, kaya naging family of curves siya ay dahil dito sa constant na yon. Kasi yung solution sa DE ay isang set of curves, which is nagdi-differ lang base doon sa value ng constant. So, therefore, para masolve natin yung differential equation ng family of curves na yon, which is the solution dun sa differential equation na bubuuin natin, ay apply lang din natin yung ginawa natin for elimination of arbitrary constants. So, sabi, to obtain the differential equation of the family of curves is to eliminate the arbitrary constants present in the parameter equation which defines the family of curves. So, apply lang din natin dito yung natutunan natin dun sa elimination of arbitrary constant, kaso dapat alam natin i-represent muna yung equation ng family of curves kasi dun tayo magsisimula kung ano bang variable yung i-eliminate natin. Okay, so para ma-illustrate, let's solve some examples. So, find the differential equation of the family of curves described by straight lines through the fixed point HK, H and K not to be eliminated. Okay, so kung i-drawing natin yung pinapahanap na family of curves, sabi daw, straight lines daw na laging nagko-contain noong fixed point na HK. Okay, so halimbawa, ito yung point na HK. Let's say H unit to. Tapos ito, K unit. So parang ito yung point na yun, di ba? So lahat daw ng lines na nagpa-pass through dito sa point HK, yun yung hahanapan natin ng differential equation. Okay? So ngayon, hanapin muna natin kung ano ba yung magiging form ng equation na fa-line natin given this condition. So di ba meron tayong point slope form of a line which is given by y minus y sub 1 is equal to m times x minus x sub 1. Ngayon, itong x sub 1 tsaka y sub 1, pwede natin yung palitan nung given point, fixed point na hk. So, parang y minus k is equal to m times x minus h. Right? Kasi sabi dun sa equation sabi dun sa problem, hindi daw dapat natin i-eliminate yung h tsaka k. Okay, so fix yun. So, therefore, kasi dito sa nabuo nating equation, yung dependent variable natin ay y, right? Tapos, yung independent ay x. Itong k tsaka h ay constant o hindi natin eliminate. Therefore, isa lang yung variable na eliminate natin. Ano yon? Itong m, which is yung slope. So, ngayon, apply natin yung natutunan natin sa elimination of arbitrary constant, wherein ang eliminate natin ay itong m. So, pwede natin gawin dito ay i-differentiate natin implicitly. So, we have differentiate natin both sides. So, derivative ng y is 1. So, 1 times dy for the implicit differentiation. Then, derivative ng negative k is constant yan. So, 0 lang. So, minus 0 equals m. Ito, constant lang din. So, itatabi lang natin sa gilid. Differentiate natin tong quantity x minus h. So, itong derivative ng x ay 1 times dx for implicit differentiation. And then, yung derivative ng negative h is constant yung h, so 0. So, minus 0. So, therefore, we have dy is equal to m times dx. Solving for m, divide both sides by dx, we have m is equal to dy over dx. Now, itong m natin na dy over dx ay pwede na nating i-substitute dito sa original equation natin para ma-cancel siya. So, parang we have y minus k is equal to m na dy over dx times x minus h. Or pwede nating i-multiply both sides of the equation by dx para ma-cancel yung denominator. We have y minus k dx is equal to x minus h dy. Ginawa ko lang dito. So therefore, this is our differential equation. Now, pwede pa nating i-transpose to sa kabila, magiging y minus k dx minus x minus h dy is equal to 0. So therefore, this is the differential equation for the family of curves that is a straight line through the fixed point hk, and hk is not to be eliminated. Okay? Kasi na-retain pa rin naman natin dito yung k tsaka h sa differential equation. Okay? Next, we have straight lines through the origin. Okay, so kung i-drawing natin yung family of curves, so straight line daw, passing lagi dun sa origin. So parang, di ba ito yung origin natin? So lahat ng lines na nagpa-pass through the origin. Okay? Hanapin natin yung differential equation ng family of curves na yon. So, di ba meron ulit tayong point slope form na y minus y sub 1 is equal to m times x minus x sub 1. Tapos itong x sub 1, y sub 1 point natin, gagawin nating laging origin kasi yun yung required sa problem. So therefore, parang y minus 0 is equal to m times x minus 0. Or simply, y is equal to mx. So therefore, ang i-eliminate natin dito sa equation natin ay itong m lang. Okay? So, implicit differentiation, we have derivative ng y is, so since y is equal to mx, hanapin natin yung first derivative. Once lang tayo magdi-derivative kasi isa lang yung constant natin na m. So, y prime is equal to simply m. Kasi derivative ng x ay 1. Or simply, we have dy over dx is equal to m. Ngayon, substitute natin tong m as dy over dx dito sa original equation. We have y is equal to dy over dx x. Or multiply both sides by dx, we have y dx is equal to x dy. Transpose natin sa kabila, itong si y dx magiging x dy minus y dx is equal to 0. So therefore, na-eliminate natin si m. Therefore, ito na yung final differential equation natin for the family of curves of straight lines through the origin. Next, we have straight lines with slope and y-intercept equal. So, represent muna natin dito yung equation of a line. So, this time, gamitin natin yung slope-intercept form na y is equal to mx plus b. So, yung m yung slope, b yung y-intercept. Sabi dito sa condition, yung lines daw, dapat yung m natin na slope ay equal doon sa y-intercept na b. Okay? So, therefore, pag ginawa natin yon, yung equation natin ay magiging y is equal to mx, tapos yung b gawin nating m na lang din. Okay? So, y equals mx plus m. So, therefore, isang variable na lang tayo at may eliminate natin tong m by finding first derivative lang kasi isa lang yung constant natin. So, we have y prime is equal to, so yung mx, derivative niyan ay simple m na lang kasi yung derivative ng x ay 1 lang, tapos itong derivative ng m which is constant is 0. So, parang y prime is equal to m. Ngayon, substitute ngayon natin ito sa original equation na y is equal to mx plus m. So, we have y is equal to, yung m gawin nating y prime, so y prime x plus m ulit na y prime. So, parang y is equal to, factor out yung y prime, we have x plus 1, tapos transform natin yung y prime as dy over dx. Actually, pwede na to, pero transform natin as dy over dx yung y prime. We have dy over dx times x plus 1. Tapos, multiply natin both sides by dx. We have y dx is equal to x plus 1 dy. Transpose natin tong y dx sa kabila, magiging x plus 1 dy minus y dx is equal to 0. So, therefore, this is the differential equation for the family of curves of straight lines with slope and y-intercept equal. Okay? Next, we have straight lines with algebraic sum of the intercepts fixed at k. Okay, so gamitin natin yung form na y equals mx plus b. So, alam natin na dito sa y equals mx plus b, ito yung b natin na y-intercept. So, therefore, para mahanap natin in terms dito yung x-intercept, isa-set natin itong y sa 0. And then, isa-solve natin yung x. So, we have 0 is equal to mx plus b. Solving for x, we have negative b is equal to mx divide both sides by m, we have x-intercept is equal to negative b over m. Okay, so kaya ko sinet sa 0 yung y kasi yung x-intercept ay magta-touch doon sa x-axis. Okay? Now, sabi, yung sum daw nung y-intercept tsaka x-intercept ay fixed na k. So, pag inad natin to, yung b plus negative b over m equal yan sa k. Okay? So, ngayon, pwede natin isolve tong b by factor muna natin tong b. So, 1 minus 1 over m na yan equals k. Tapos, magiging, gawin nating single fraction tong 1 minus 1 over m. Magiging m, tapos m minus 1 equals k. So, we have b is equal to, cross-multiply natin tong m sa taas, itong m minus 1 sa baba, magiging mk over m minus 1. So, therefore, pwede natin ipalit itong b in terms of m dito sa original equation natin. So, magiging y is equal to mx plus mk over m minus 1. So, itong k, constant yan. So, hindi yan natin makakonsider na constant na eliminate. Dapat nandun yan sa equation. Itong m lang yung i-eliminate natin, which is 1 constant na lang kasi ni-represent natin itong b in terms of m. So, therefore, isang beses lang tayo magdi-differentiate. Okay? So, mag-differentiate na tayo. 1. So, y prime is equal to, derivative ng mx ay simply m plus, derivative nito, diba sabi natin, itong mk over m minus 1, constant yan. So, pag derivative natin yan, 0 na lang. So, therefore, y prime is equal to m. Okay? So, ngayon, pwede na natin i-substitute itong m in terms of y prime dito sa original equation natin na y equals mx plus b. Or sorry, dito sa nabuo nating equation na y equals mx plus mk over m minus 1. So, therefore, we have y is equal to, m natin is y prime na, tapos x plus m natin is y prime times k over m natin is y prime minus 1. Okay, so, transpose ko na lang to dito para maka-equate tayo sa 0. Magiging 0 is equal to xy prime minus y plus y prime k over y prime minus 1. Tapos, multiply natin both sides of the equation by y prime minus 1 para mawala yung denominator. So, parang 0 is equal to xy prime minus y multiplied by y prime minus 1 plus, ito, makakancel, y prime k. Okay, so therefore, this is the final answer. Na-eliminate na natin yung constant na m. Okay? Next, we have circles with centers at the origin. Okay, so this time, mga circle naman tayo. So, kung i-graph natin yung families of curves of circle with center at the origin, so ito yung center nila. Pwedeng iba-iba tayo ng radius, pero dapat pare-pareho sila ng center na origin. So, gamitin natin yung equation of a circle, yung center radius form. So, x minus h squared plus y minus k squared is equal to r squared. Okay? So, since sabi yung center daw natin ay laging origin or 0, 0, pwede natin i-substitute yon. So, parang x minus 0 squared plus y minus 0 squared equals r squared. Or simply, x squared plus y squared is equal to r squared. Ngayon, napansin nyo, itong remaining equation natin ay isa lang yung constant, which is yung r. So, therefore, once lang tayo magdi-differentiate para ma-eliminate natin yung constant na r. So, implicit differentiation na lang, we have derivative both sides of the equation. We have derivative ng x squared is 2x dx plus derivative ng y squared is 2y dy equals derivative ng r squared, which is constant, ay 0. Okay, so therefore, ito na yon. Pwede natin i-divide both sides by 2 para makancel lang tong 2. We have x dx plus y dy is equal to 0. So therefore, this is the differential equation of family of curves of circles with center at the origin. Okay? Next, we have circles with center on the x-axis. Okay, so kung i-draw natin yung sketch ng family of curves natin na to, meron tayong mga circles na dapat yung center nila ay nagpa-pass through doon sa x-axis. So kahit anong radius nila, as long as yung center nila ay nandun sa x-axis. So therefore, using the center radius form, we have x minus h squared plus y minus k squared is equal to r squared. Kung yung center natin ay laging nandito sa x-axis, therefore, yung coordinate natin lagi para doon sa k natin ay laging 0. Kasi yung equation nung x-axis is y is equal to 0, right? So therefore, pag sinubstitute natin yung 0 lagi dito sa k, magiging x minus h squared plus y minus 0 squared is equal to r squared. Okay, kasi lagi yung form nung center natin ay h, 0. Kahit anong h, which is, i-represent natin na h as variable. So therefore, meron tayong dalawang unknown, madalawang constant sa family of curves natin. Simplifying further, we have x minus h squared plus y squared equals r squared. So therefore, meron tayong dalawang constant na eliminate, itong h at r. So therefore, dalawang beses tayo magde-derivative. Now, use natin yung implicit differentiation on both sides. So ngayon, ibang way ng implicit differentiation yung gagawin ko. So, diba sa mga previous example ko, kada differentiate natin, both x and y, nilalagyan ko ng differential na dx or dy. Ngayon, i-consider natin na yung x natin ay independent variable, therefore, dun with respect yung derivative natin. So, hindi na natin lalagyan ng differential dx yung derivative nung x natin kapag nag-differentiate tayo. But instead, i-carry over natin lahat doon sa y or yung dependent variable natin yung mismong dy over dx or y prime. So, kada differentiate natin dun sa y, lalagyan natin siya ng dy over dx or y prime. Sa derivative nung x natin na variable, wala na tayong ilalagay na any differential. Okay, so try natin yon. So, derivative ng x minus h quantity squared ay chain rule. So, 2 times x minus h, tapos magiging 1 yung exponent, then derivative ng inside na x minus h is simply 1 na lang, right? Tapos, di ko nalagyan ng dx, ha? Dex, ito namang y squared, derivative niyan ay 2y, and then, sabi ko nga, i-carry over natin lahat ng derivative or differential dito sa y. So, magkakaroon siya ng y prime or dy over dx. So, gamitin ko na lang tong y prime. Okay? Equals, derivative ng r squared is 0. Kasi constant siya. Okay? Now, we can transpose 2y prime sa kabila, magiging 2 times x minus h is equal to negative 2y prime. And then, we can cancel out the 2 here so that we can solve for h by transposing negative h sa kabila, itong negative y prime sa kabila. So, parang, di ba, x minus h is equal to negative y prime na lang yan after makancel itong 2. So, therefore, transpose si h dito, transpose si y prime dito, magiging h is equal to x plus y prime. Okay? Ngayon, since itong right side natin ay constant h, kapag nag-implicit differentiation ulit tayo once, kasi kailangan natin ng dalawang beses mag-differentiate, right? Maka-cancel na natin yung h. Therefore, yun na yung final form ng differential equation natin. So, therefore, we have implicit differentiation both sides. So, dito sa left side, derivative ng x ay simply 1 lang. So, again, wala tayong differential na ilalagay kasi i-carry over natin lahat dito sa y. Okay? Plus, this time, y prime, derivative natin, product rule uli, copy muna natin yung first function na y, so y, and then multiply by the derivative of y prime. So, derivative of y prime is simply, so therefore, yung derivative ng y prime ay magiging y double prime na, kasi naka first derivative na siya. Tapos, pag derivative mo pa, second derivative na yon. So, kaya y double prime. Plus, this time, derivative ng y prime, copyhin natin, times derivative naman yung y, which is 1 lang plus yung y prime nga. Okay? Kasi doon na natin i-carry over yung differential. Okay? Equals, derivative ng h is 0. So, therefore, wala na tayong variable or constant. So, therefore, na-eliminate na natin yung constant na h. So, therefore, ito na yung final answer natin. y double prime plus, ito, pwede natin gawing y prime squared and then plus 1 is equal to 0. So, therefore, this is the final answer. Okay? Next, we have all circles of radius 1 and centers on line y equals x. Okay, so kung i-sketch natin yung graph ng family of curves natin ng circles na to, Sabi daw, yung circles, yung centers daw nila ay nandun sa line y equals x. So, di ba ito yung line na y equals x? Passing through the origin. So, equal yung y tsaka x. So, lahat daw ng centers ng circle natin na may radius 1 lang dapat, yung center niya ay nandito. Okay? So, parang ganyan. So, therefore, using the center radius form of a circle, we have x minus h squared plus y minus k squared equals r squared. Etong r, papalitan lang natin ng 1 kasi 1 lang yung radius dapat. Tapos itong hk or yung center ng radius ng circle natin, dapat equal sila kasi base dito sa given, dapat under siya dun sa line na y equals x, which is identity function. So kung ano yung value mo ng x, yun din yung value mo ng y. Dapat equal yung x sa y. Kung h mo ay 1, dapat yung k mo ay 1. Or 2 mo ay 1, h mo ay 2, k mo rin ay 2. So therefore, pwede nating i-let na h is equal to k. So therefore, mababawasan yung constant natin, magiging isa na lang. So substitute natin dito na x minus h squared plus y minus itong k, gagawin ko na lang ding h para isang variable na lang sila since equal naman sila. So therefore, ito yung magiging equation natin for the family of curves of circle with radius 1 and centers on line y equals x. So therefore, isa lang yung constant natin na eliminate. So once lang tayo magde-derivative. Okay, so gamit na lang tayo ng implicit differentiation. So, differentiate natin both sides of the equation. So, we have x minus h quantity squared derivative is 2 times x minus h times 1. Right? Plus, ito, 2 times y minus h. And then, derivative of y is 1 times, dahil implicit differentiation tayo, apply ko yung ginawa natin kanina sa previous example, dito natin i-carry over yung y prime or dy over dx. So, dito sa x, din ako naglagay ng differential na dx. So, parang nandito na sa y prime. Equals, derivative ng 1 or constant is 0. Okay. So, therefore, we can simplify this as 2 times x minus h plus 2 times y minus h, y prime is equal to 0. Then, we can now solve for h in this equation. Mapansin nyo, pwede pa natin makancel tong 2, so magiging x minus h plus y prime minus hy prime. So, nedistribute ko lang tong y prime equal 0. Pagsamahin natin lahat ng may mga h, transpose ko sa kabila, yung may mga wala sa left side. So, x plus y prime is equal to positive hy prime plus h. And then, factor out natin yung h dito sa right side. Magiging h times quantity y prime plus 1. And then, x plus y prime sa left side. Now, solving for h, divide natin both sides by y prime plus 1. So, we have h is equal to x plus y prime over y prime plus 1. Ngayon, pwede na nating i-substitute itong h in terms of this expression dito sa original equation natin na in terms of h lang yung constant. So, pag ginawa natin yon magiging, so, x minus yung h, ito yung sa-substitute natin, x plus y prime over y prime plus 1, then squared plus y minus h din na to, x plus y prime over y prime plus 1, quantity squared, and then equal sa 1. So, simplify natin to. So, y prime plus 1, etong first part, gawin nating single fraction. So, magiging x times y prime plus 1 minus x plus y prime, quantity squared, plus ito rin, magiging y prime plus 1 LCD ay magiging y times y prime plus 1 quantity minus quantity x plus y prime squared equals 1. Simplify natin. So, dito muna tayo, distribute natin tong x, magiging xy prime plus x, and then itong negative, distribute natin, negative x minus y prime over y prime plus 1, then squared. Plus, ito rin, distribute natin itong y, magiging y prime plus y, itong negative distribute minus x minus y prime over y prime plus 1, quantity squared equals 1. Now, combine similar terms dito. Meron ba? So, makakancel natin to. Tapos, matitira ay xy prime minus yy prime over y prime plus 1 quantity squared. Plus, dito rin, makakancel natin itong yy prime, matitira ay y minus x over y prime plus 1 quantity squared equals 1. Okay, so distribute natin to square sa numerator and denominator, magiging xy prime minus yy prime squared over y prime plus 1 squared plus ito rin y minus x squared over y prime plus 1 squared equals 1. Law of exponents. Tapos pagsamahin natin to as a single fraction. Y prime plus 1 quantity squared. Tapos yung denominator, dahil similar fraction sila, add na lang natin. Xy prime minus yy prime squared plus y minus x quantity squared is equal to 1. Tapos, eto, pwede pala natin tong i-factor. Itong expression na to, magiging y prime times x minus y quantity squared plus y minus x squared over y prime plus 1 squared equals 1. Tapos, distribute natin itong exponent, magiging y prime squared times x minus y squared plus y minus x squared over y prime plus 1 squared equals 1. Now, itong x minus 1 tsaka y minus x, pwede nating i-factor out. Tapos ito, ilabas ko na lang tong negative nito para pareho sila. Para maging ano to, y prime squared negative of y minus x squared. Tapos itong negative, parang mawawala lang din kasi didistribute mo yung squared. So, parang positive na rin siya. So, parang y prime squared na siya. Then, y minus x squared plus y minus x squared over y prime plus 1 squared equals 1. So, factor out na nga natin to, magiging y minus x squared and then y prime squared plus 1 over y prime plus 1 squared equals 1. Pwede natin i-cross multiply itong y prime plus 1 quantity squared sa right side, magiging y minus x squared times y prime squared plus 1 equals y prime plus 1 quantity squared. So, therefore, this is the final answer. Okay, so basically, yan yung families of curves. So, i-apply nyo lang din yung natutunan nyo about elimination of arbitrary constants. Tapos, ibabasa nyo doon sa given statement, doon sa problem, kung ano yung magiging form ng equation or kung ilan yung constant na eliminate nyo. Okay? So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.